Good evening, everyone. Welcome back to Future Automation. I'm Rohini here, going to give you a podcast about convolution neural networks. So, in this case, I have attached the diagram also in the video which you are seeing now. So, artificial intelligence has been a major growth in bridging the gap between the capabilities of the humans and machines. So, the agenda for this AI field is to enable machines to view the world as humans do. In order to perceive it in a similar way, that is, you have to use the knowledge for the multitude of tasks such as image and video recognition, image analysis, classification, media recreation, recommendation system, etc. So, the advancements in computer vision with deep learning has been constructed and it has been structured into one particular algorithm called convolution neural network. So, definition about convolution neural network, as you all know that convolution neural network CNN is a deep learning algorithm which can take an input image that is a learnable weight and biases to various objects in the image and be able to differentiate one from the other. That is, the pre-processing required in the convolutional neural network is much lower as compared to other classification algorithm because it's having some filters that is enough for training, and convolutional neural network has the ability to learn all these filters or the characteristics. So the architecture of CNN is that is the connectivity pattern of the neural network. So before that, like as I told you already, that is NN neural network. So you have to know what is neural network. So neural network is a separate topic that it involves nearly like 1 week to teach because it has lots of things inside. So because it's also a series of algorithms that recognize relationship in a set of data through a process that mimics the way the human brain operates. So that is what is all about. It's a simple definition that I am telling about. So neural network algorithm is a form of ML algorithm with a structure based upon the human brain. Like other kinds of machine learning algorithm, they can also solve problems through trial and error without being explicitly programmed. And there are different types of neural network like feed forward neural network, multi-layer perceptron, convolutional neural network, etc. So in simple words, a neural network can adapt to changing input so that the network generates the best possible result without needing to redesign the output criteria. So like whatever I am telling now is like very weird for all of you because that is a separate topic that it involves 1 week of learning podcast explaining you the mathematics beyond that. So coming to the CNN, the architecture of the convolutional neural network is the connectivity pattern of neuron in the human brain and was inspired by the organization of visual cortex. So why convolutional neural networks over feed-forward neural networks? In case of extremely basic binary images, the method might show an average precision score while performing prediction of classes but would have little to no accuracy when it comes to complex images having pixel dependency. So convolutional neural network is able to successfully capture, that is what I am trying to say, capture the spatial and temporal dependencies in an image through an application of relevant filters. That is, the architecture performs a better filtering to the image dataset, which I am showing in the video, due to the reduction in the number of the parameters involved and reusability of the weights. So in the other words, I would say the network can be trained to understand the sophistication of the image better. That is, the network can be trained so in order to understand the image. So that's what the main thing that I am trying to say. For example, we have an RGB image which has been separated by its 3 color plane, that is red, green and blue, that is RGB. There are a number of such colors spaces in which the images exist, for example HSV, CMYK, etc. So the role of the convolutional neural network is to reduce the images into a form which is easier to process without losing features which are critical for getting a good prediction. So this is important when we are to design an architecture which is not only good at learning feature but also is scalable to massive data sets. So image, for example, in the case of images with multiple channels, for example RCP, the kernel has the same depth as that of the input image. So matrix multiplication will be, I am telling in mathematics, K1 1, K1 2, K1 I1, K2 I2, K3 I3, and all the results are summed with a bias to give us a one depth channel convoluted feature output. And there are various architectures of CNN available. So LENET, CONVET, which we are seeing now, that is convolution. Similar to that, LENET, AlexNET, Google NET, there are lots of CNN topics out there. Apart from this, why do you mean by convolution? Actually, convolution comes from the Latin word that is convolve, where to convolve means to roll together. That is, convolution is the mathematical operation on two functions, for example f and g, to construct a third function that represents how the shape of one is modified by the other. So it is the integral calculating how much two functions overlap as one passes over the other. Assume convolution as the way of combining two functions by multiplying them. So whenever we see an image, what our brain looks for the features in the image to classify that image. We categorize things by recognizing the features. To prove this thing, here there are two images which we will classify, as you are seeing in the video, two-faced man. So in the two-faced man, if we look to the right side of the image, we will see a person looking towards the right side. While if we look in the center, we will perceive that the person is looking towards us. Does our brain struggle a lot in identifying these different scenarios and is confused with if the person is looking in right or towards us? Oh, this happens because our brain studies for the features in the image and then assume what we take. So it's all about it. How the computer sees an image, that is what all are excited. As we all know, an image is the matrix of pixels. If there is a black and white image, then we will get a 2D array. While if we passed a color image, then we will get a 3D array, which means it has an extra parameter for depth, which is RGB channel as shown. The pixel value lies between 0 and 255, and images are stored in bytes, that is 0 to 255. So that is what I am trying to say. So if there is a black and white image, then we will get a 2D array. So if you are going to pass a colored image, then that is a 3D array. So CNN and like as of now we have discussed CNN and how the image is interpreted and classified on the basis of feature in the image. Now next, in order to brief about CNN are very similar to ordinary neural networks because they are made up of neurons that have learnable weights and biases. Because each neuron receives some input, performs a dot product, and optionally follow it with a non-linearity. That is, for example, input A to B, C, D. That means A1, X1, like that it will come. So A, B, A plus A, C plus A, D. That is what. Each neuron, they are made up of neurons that have learnable weights and biases, where each neuron receives some input, performs a dot product, and optionally follows it with a non-linearity. So the whole network still expresses a single differentiable score function from the raw image pixels on one end to class scores at the other end. And still they have some loss functions, that is SVM or softmax, on the fully connected layer, and all the tips or tricks we developed for learning regular neural networks. So and don't worry about it. I will after publishing the neural network, I will give you a demo also. Demo in the sense like the mathematical demo and the brief explanation about it, because it's for the people who are experienced in data science or data scientists, or people who are working in data science for more than 2 years or 3 years will learn all this. Because it is not for the freshers, so don't worry. But anyway, learning is important, so learn whatever, learn or listen whatever you want. Like, it is not bad to learn, nothing like that. So convolutional neural network architecture is in the simplest case a list of layers that transforms the image volume into a output volume. And there are a few distinct types of layers, that is ReLU, CONV, POL are by far the most popular layers. That is ReLU, POL, CONV, FC. These are the popular layers. Each layer accepts an input 3D volume and transforms it into a output 3D volume through a differentiable function. And each layer may or may not have parameters, and each layer may or may not have additional hyperparameters too. So, and this is what is all about CNN. A brief brief explanation. It's a brief explanation about the convolutional neural network. So in deep learning, what they will tell is the convolutional neural network, CNN or CONVNET, is a class of deep neural networks most commonly applicable to the visual images. So they are also known as shift invariant or space invariant ANN. That is, ANN means artificial neural networks. So CNN is otherwise called as shift invariant or space invariant artificial neural networks. There are lots of concepts called single layer perceptron, multi-layer perceptron. So I don't want to confuse it now, but I want to tell you that they have applications. These CNN have applications in image, mostly in image recognition, video recognition, recommendation systems, NLP, and image classifications, and also in the financial time series. I have used CNN in my time series algorithm, like for the time series data, in order to increase my accuracy. So machine learning, deep learning, there are lots of differences. So I have also published a video on difference between deep learning, machine learning, and AI. If you want to check out, go to my link in the description box and view that also. Okay, CNN or regularized version of multi-layer perceptron. So multi-layer perceptron means it's a class of feed-forward neural network. The term multi-layer is called loosely to any feed-forward neural network. So MLP, that is multi-layer neural network. And multi-layer perceptron usually means fully connected network. That is each neuron in one layer is connected to all neurons in the next layer. The fully connectedness of these networks makes them prone to overfitting data. Typical ways of regularization include adding some form of magnitude measurement of weights to the loss function. And CNN takes a different approach towards regularization and also take an advantage of hierarchical pattern in the data and assemble more complex pattern using simpler and smaller patterns too. And CNN are on lower extreme, and it is little bit complicated when compared to all the other algorithms, but it will give you excellent results based upon the data that you are going to use. And CNN consists of input layer, output layer, as well as multiple hidden layers. The hidden layer of CNN typically consists of the series of convolution neural network. The hidden layer of CNN typically consists of series of convolutional layers that convolve with the multiplication or other dot product. That is, the activation function is commonly known as ReLU layer. It has a mathematics behind it and is subsequently followed by additional convolutions such as pooling layers, fully connected layers, and normalization layers, referred to as hidden layers because their input and output are masked by the activation function and final convolution. And convolution layers convolve the input and pass it its result to the next layer. This is similar to the response of the neuron in the visual cortex to a specific stimulus. That is, each convolutional neuron processes data only for its respective field. Although fully connected feed-forward neural networks can be used to learn features as well as classify data, it is not practical to apply this architecture to these images. A very high number of neurons could be necessary even in the shallow architecture due to very large input sizes associated with the images. For example, 100 to 100, that is 10,000 weights for each neuron. It's a bigger image in the second layer. So the convolution operation brings a solution for this problem as it reduces the number of free parameters, allowing the network to be deeper with fewer parameters. This is what is all about. And you have to know also about pooling, fully connected, respective field, weights, everything. You have to Google and you have to learn about it. So that is what the thing that I am trying to say. So hope this video is definitely useful for you. So if you want to learn more about CNN, I will give you the CNN links also. That is a convolutional neural networks deep learning tutorial links also in the description box below if you want to study it further. So this may be your first podcast to learn CNN, like to learn CNN about CNN is very important. For the fresher, it's not important. Definitely, it's not important. But for experienced people, CNN is must. That's what I would say, because it will be useful for you in some project or in some way in your life. So if you are in a data science career, and thank you so much. Keep supporting, keep subscribing. Thank you so much. Thanks.